Welcome student. Today we learn about mechanical property angle of contact of liquid. When a liquid surface comes in contact with a solid surface, it forms a meniscus which can be either convex or concave. The angle of contact theta between a liquid and solid surface is defined as the angle between the tangent drawn to the free surface of the liquid and surface of the solid at the point of contact measured within the liquid. When the angle of contact is acute, the liquid forms a concave meniscus as shown in the figure at the point of contact. For example, water-glass interface forms a concave meniscus. When the angle of contact is obtuse, it forms a convex meniscus. For example, mercury glass interface form a convex meniscus. This difference between the shape of meniscus is due to the net effect of the cohesive force between the liquid molecules and adhesive force between the liquid and solid molecule. Phenomenon of angle of contact on the basis of intermolecular force. The shape of meniscus, that is concave meniscus, is form a acute angle of contact. Consider kerosene take in a glass bottle. The figure shows the acute angle of contact between a liquid surface. Consider a molecule such as A on the surface of the liquid near the wall of the container. Its sphere of influence is partially in liquid, partially in solid, and partially in air as shown in figure. The molecule experience both the cohesive as well as adhesive force. In this case, since the wall is vertical, the net adhesive force AP acting on the molecule A is horizontal. Net cohesive force AC acting on the molecule is directed at nearly 45 degree to either the surface. Magnitude of adhesive force is so large that the net force AR is directed inside the solid. For equilibrium or stability of a liquid, the net force AR acting on the molecule must be normal to the liquid surface at all points. For the resultant force AR to be normal to the tangent, the liquid near the wall should be filled up against the solid boundary so that the tangent AT to be a liquid surface is perpendicular to AR. Due to this, it makes the meniscus concave. Obviously, such liquid wet the solid surface. Phenomenon of formation of meniscus, that is obtuse angle of contact. When mercury taken in a glass bottle, its formation of obtuse angle of contact between liquid and solid. Consider a molecule A on the surface of a liquid near the wall of container. The molecule experiences both the cohesive as well as adhesive force. In this case also, the net adhesive force AP acting on the molecule A is horizontal since the wall is vertical. Magnitude of cohesive force is large than the net force AR is directed inside the liquid. For equilibrium or stability of liquid surface, the net force AR acting on all molecule similar to molecule A must be normal to the liquid surface at all point. The liquid near the wall should be trips inside against the solid boundary. This makes the meniscus convex so that its tangent AT is normal to AR. Obviously, such liquid does not wet that solid surface. Phenomenon of zero angle of contact. Figure shows that the angle of contact between a liquid which is highly pure water which completely wet a solid with the clean glass surface, the angle of contact in this case is almost zero. In this case, the liquid molecules near the contact region are so less in number that the cohesive force is negligible. That is, vector AC is equal to 0, and the net adhesive force itself, it is resultant force, that is vector AP is equal to vector AR. Therefore, the tangent AT is along the wall within the liquid and angle of contact is 0. Phenomenon of angle of contact at a right angle. Consider a hypothetical liquid having angle of contact 90 degree with a given solid container as shown in figure. In this case, the net cohesive force AC is exactly at 45 degree with either the surface, and resultant force AR is exactly vertical along the solid surface. Condition for acute and obtuse angle of contact. For acute angle of contact, vector AP is greater than AC by root 2, and for obtuse angle of contact, AP is less than AC by root 2. Shape of liquid drops on surface. When a small amount of liquid is dropped on plain solid surface, the liquid will either spread on the surface or will form a droplet on the surface, which phenomenon will occur depend on the surface tension of liquid and angle of contact between the liquid and solid surface. Consider the surface tension between the liquid and air as well as that between solid and air. Let theta be the angle of contact for the given solid liquid pair. T1 is the force due to surface tension at the liquid solid interface. T2 is the force due to surface tension at the air solid interface, and T3 is the force due to surface tension at the air liquid interface. As the force due to surface tension is tangential to the surface in contact, direction of T1, T2 and T3 are shown in the figure. For equilibrium of the drop, T2 is equal to T1 plus T3 cos of theta. Therefore, the cos of theta is equal to T2 minus T1 by T3. From this equation, we get the following cases. If T2 is greater than T1 and T2 minus T1 is less than T3, then cos theta is positive and the angle of contact theta is acute as shown in figure. Case second, if T2 is less than T1 and T1 minus T2 is less than T3, then the cos of theta is negative and angle of contact theta is obtuse as shown in figure. For example, mercury in contact with glass. Case 3, if T2 minus T1 is equal to T3 and cos of theta is equal to 1 and theta is nearly equal to the 0. Happens in water in contact with glass. Case 4, if T2 minus T1 is greater than T3 or T2 is greater than T1 plus T3, cos of theta is greater than 1, which is impossible. The liquid spread over the solid surface and drop will not be formed. Factors affecting the angle of contact. The value of the angle of contact depend on the some factors. First, the nature of the liquid and solid pair in contact. Second, impurity. Impurities present in the liquid changes the angle of contact. Next, temperature of the liquid. Any increase in the temperature of the liquid decreases its angle of contact for a given solid liquid surface. The angle of contact is constant at a given temperature. Thank you.